Centripetal force is like one kind of a circular motion also. Okay. So today
We are only going to do centripetal force today.
no. There are three topics that is centripetal force, circular motion of a car on a banked road, and the circular motion. Motion in
What?
a vertical circle, that is circular motion you can say. Okay.
Okay.
So first of all we'll talk about centripetal force. So a body moving along a horizontal circular path, centripetal force is mv square by r. If
Are you sharing your screen, sir?
my screen is not visible,
No, it's just a dark circle.
just a moment. Yeah.
I thought you were not sharing it.
Okay. Is it shared now?
Uh, yes.
Okay. My mistake. So today we are going to talk about centripetal force and motion on a banked road. Okay. And the third topic is motion in a vertical circle. So we'll try to finish it, these three topics. So whenever a body is moving in a circular motion, okay. So have you seen well of death?
Yes.
Okay. So in that well of death, a driver is moving his car or bicycle, car or motorcycle in a circular path, but he
Yes.
doesn't fall inside. Why?
Because of friction.
No, because not of friction, because of centripetal force. Okay.
I don't understand. Like, how's centripetal force stopping him from falling?
Yeah, centripetal force is always, first of all, we'll understand what is centripetal force. A force required to make a body move along a circular path with uniform speed. So, if a body is moving in circular path, like this circular path, let us say along this circular path, a body is moving. So, you know that at this instant of time, its velocity will be in this direction. Velocity will be in this direction. Velocity is always tangential, isn't it?
Yes.
Okay. So, at this juncture, that an inward force will be there, that is called as centripetal force. At this point, same force will be here, same force will be here, same force will be here. But as it is changing time to time, so that's why this motion is continuous. There is no break at all. It is called as uniform circular motion. Okay. Uniform circular motion. Why it is called uniform circular motion? Uniform means the same velocity. Okay.
Yeah.
Sorry, I'm the same speed. Same speed.
Okay,
Not
velocity will change, okay, because direction is
yeah,
changing.
velocity is changing with each and every second. Velocity is getting changed, but your speed is the same. So that's why it is called as uniform circular motion. So there is an inward force. That force is keeping that motion continue. Okay. So that force is said to be the centripetal force, and this force is equal to mv square by r. Just note it down. It is mv square by r. As it is a circular motion, so there will be omega also. What is omega? Omega is angular velocity. Okay. Got my point?
Angular velocity.
Omega
It's
is,
basically velocity.
yeah, it is a velocity, one kind of velocity, but angular velocity. What is your the formula of speed? Formula of speed is what? Distance by time.
Time.
So, what is omega? Omega is distance, but the angular distance. If you are saying angular distance, that means it is theta. Okay. So it is basically delta theta over delta t. Got my point?
Yes.
So that is your angular velocity, and omega is always equal to 2 pi frequency. Omega is 2 pi into frequency, okay, and frequency is 2 pi by t.
2 T. Okay.
Okay, frequency is, sorry, not frequency is 2 pi by t. Frequency is 1 by t. Time period upon 1 upon time period is frequency, and 1 upon frequency is time period. Okay.
Yeah. What's that formula say? F is equal to mr omega square.
Because of V is equal to R omega. V is equal to R omega. Okay. So if you keep V is equal to R omega here, so that becomes mr omega square. Okay. Got my point?
Yes.
Any doubt? Just note it down.
Done.
Done? Okay, very good. So now just try to do that 70th example. So these formulas will be used here in these
Okay, sir.
questions. Do it fast, then we'll study another topic.
Yes.
If you are talking about a string that is taking a load and moving circular, so how many forces are there?
First
Centripetal,
there will be tension.
tension. So tension will be balancing what?
Tension will be balancing the
Centripetal force.
why?
There are only two forces.
But the string is not in circle, right? It's just being moved in a circle.
Yeah, that's why it is moving in a circle, so it is a circular motion.
So it's just being moved like that.
Yes. Okay, it is rotated in a horizontal circle like this. It is rotating like this. Okay,
Okay.
string is in your hand. So there is only tension and centripetal force. They will balance each other, isn't it?
Yeah.
So you can directly put your force equal to tension equal to centripetal force.
Yeah.
Got it?
Yes.
Just calculate it fast.
Okay.
Done?
No, sir. One second. Not able to. I'm not understanding it.
What is the problem in this question? Yeah, that is
No,
very
no, I'm
simple.
not able to understand how to solve this question. Trying to put it in formulas, but I'm not able to solve it.
A string breaks under a load of 4.8 kg. That means the maximum tension it can sustain. That
Yeah.
is 4.8 kgf. So how much will be the tension? That
48 Newton.
48 Newton. So tension will be 48 Newton. Okay, that can be sustained by that string. Mass is 0.5 kg is the test. So that is moving in a horizontal circular motion. So that F will be equal to mv square upon r,
Yeah.
and that will be provided by the tension of the string. Okay.
Yeah.
So what is F? F is 48 equals to m is 0.5. V I think
Exactly.
we have
We
to
were.
find, and one end of the string is 2 meter. That means the radius of the circle,
Yes.
isn't it? So that
The
is
radius is 1
why it is 1.
because it is attached to a string of length 2 meter, right? So the diameter is 2.
If this is a string of 2 meter, okay,
Yeah.
If I am rotating it, so it will not be a diameter, it will be a radius.
Well, then how will it be a radius? 1 second. How does that even matter? We're just rotating the tip, right? How does that matter? I don't understand. How will we?
It's a
How?
horizontal circle, yeah. Your finger, your thumb will be at the center and it is rotating around your thumb.
Okay, like that basically.
Yes. So,
Okay, so the pen. Okay, okay, understood.
so that will
2
behave like
meters.
the radius. Okay.
Okay.
So he
Yes.
is asking you, calculate the greatest number of revolutions that the mass can make without breaking the string. So you need to find the greatest number of revolutions. Number of revolutions means frequency.
Number.
Frequency.
Yes.
Okay. We told you V is equal to R omega and omega is 2 pi f.
D. Yeah, 2 pi f.
So f will be V by 2 pi r, isn't it? Okay.
Yes.
So from here, what is V? So we can find out V as well over R. So V square I can put it 48 R by 0.5. That means it will be 96 R. So that is your V square. So we put V as 2 pi R F. So if we put V as 2 pi R F, so if we make it a square, so that becomes 4 pi square R square F square, isn't it?
Yeah.
Is equal to 96 R. 1 R cancelled. So by this expression, we can find out your F. Got my point?
Yes.
I think this is pretty simple.
Yeah.
Okay, very good.
Let me note it down.
Okay. So now are you ready for the next topic?
1 second, sir. Let me note it down.
Okay, okay. And this is another example. You can do it in the same manner.
Yeah.
Got it? And Vihan, keep on practicing, okay?
Yes, sir.
Done?
1 second, sir. Done.
Okay. So now what you should do, You just finish example 71 and these are some questions for your practice. Okay, if you have any doubt, just send me your doubts. Okay, we'll discuss
Yes.
it in the next class. Got it?
Yeah.
Okay, now we'll see circular motion of a car. Okay,
What about centrifugal, sir?
sorry,
What about we have only done centripetal, right? What about centrifugal?
where is centrifugal?
There's also centrifugal.
Yeah, in your syllabus it is centripetal only.
Let me send you a photo, sir.
Okay, we'll discuss that. We'll discuss it also. But first of all, we'll discuss the remaining topics. If there is any remaining topic, just send it to me. We'll see it. Vihan, if there is a remaining topic, we'll see it later on in tomorrow's class. Let me finish it today. Hello. Hello.
Yes, sir. I sent it to you.
Okay. No issues. We'll discuss that also. If let me finish it today. If there is any topic remaining, you just send me whatever is remaining. Okay. So let me finish it first. It is a motion of a car on a circular level road. Okay. It is a circular road, but it is a level road. There are two situations. First, you are going on a level road. Level means it is a just horizontal road, plain, but it is circular. You're taking turn. Okay. So that we'll discuss, and we'll discuss that scenario also if you are on an inclined plane. Okay. So if you are in level road, so what type of forces are there in the picture? That is your tire of first tire, that is your second tire, we can say. Okay.
Yeah.
And let us say the friction of first tire is F1, friction of second tire is F2. And the weight of the car will be downward, that will be mg. Let us say the mass of the car and person sitting inside the car, they have combinedly mass of m. So that entire weight will be mg. Okay.
Okay.
The reaction
You won't
force.
consider the normal between the car and the person.
Yeah. No. We are not considering it. We are just considering it the single body. Okay. So let us say the reaction force of the left part is R1, reaction force of the right part is R2. So the total reaction force will be R1 plus R2. And what will be balancing that R1 plus R2? Mg only?
The mg. Yes.
Mg only. So R1 plus R2 will be balanced by Mg. And that friction force, that is inward. So that friction force, because it is a circular motion, so that friction will provide you centripetal force. Okay? Understood the concept? Just see here, Vihan.
Yes.
So that is F1, that is F2, mu into R1 plus R2. Okay. I told you yesterday friction force is mu R. Force of friction is mu R.
Okay.
Okay. So the total force of friction will be F1 plus F2, that will be mu R1 plus R2, and R1 plus R2 will be balanced by mg. So we can replace R1 plus R2 as mg. Got my point? Okay.
Yes, sir.
Now, to sustain that car on the road, what is required? Your friction force.
Yes, friction force.
Your friction force must be greater than centripetal force. Okay.
Friction must be-
Just remember
But
this,
why would centripetal active?
because it is a circular motion. You are taking a turn on a circle.
But still, like we are on the road, right? So,
But it is a circular road, yeah. It is a circular road.
so it would still act.
Your car is moving in a circular fashion.
Yeah, but like why would? So you're saying it would still try to pull it towards the center of the circle in the turn?
Yes.
Okay.
Okay. So just write down that condition. Your force of friction must be greater than the centripetal force to make it sustain on the road. If your force of friction is lower than the centripetal force, then your car will skid.
Force of friction, then it will skid.
Yeah. So it must be always greater than the centripetal force. Just write it down. That question asks many times.
Okay.
Okay.
When
So,
taking turn, right?
yeah.
Okay, is that why when vehicles skid, that means the centripetal force is greater?
Yeah. So whenever you have lesser friction, that means the chances of slipping is more. Isn't it? In rainy season, what happens? Your road becomes lesser, friction is less there. Isn't it? In rainy season.
Yeah.
So lesser friction, greater chance of slipping.
But what happens when something is slipping when doing a straight road as well? Then no centripetal is acting.
That is also, yeah, you are just applying brakes. There is some kind of circular motion, some sort of
Okay.
circular motion for a movement. If it
Okay,
is a
for
straight,
example.
if it is a straight and balanced motion, there will not be any chance of
Okay,
slipping.
the car's tire is moving.
Yes,
Okay.
yes,
Vehicle slip when centripetal is greater.
yeah. Centripetal, your friction must be greater than centripetal.
No, then it will continue moving, right?
Yeah.
Okay.
Okay. So that is the condition. So that friction force is greater than the centripetal force. So mu mg is greater than mv square upon r, or we can say v square upon rg is lesser than mu, or we can say v square is lesser than mu rg. Okay. So that we can say mu is lesser than under root mu rg. Isn't it?
Yes.
So v is lesser than or equal to mu rg. So you can see here v is depending upon mu r and g. Got my point?
Okay. Yes.
Okay. So if you want to keep your velocity more, means your speed is more, then
One
what?
second. So why is it depending on G again?
G is a constant, yeah.
But why would it depend on it?
It is not depending upon G.
You just said V is depending on mu R and G.
G is a constant. So basically it depends upon mu and R. That means if you have greater friction, your chance of slipping is less. Okay.
Greater friction, chance of slipping is less.
Greater the radius, chance of slipping is lesser. Okay. If you are taking smaller radius, then you will slip very fast. Got it?
Okay.
So sometimes question may be asked that what is the minimum velocity to make a turn? So mu will be given to you, r will be given to you, and g is your known. Okay,
Yes.
understood? So just write down this formula. To make a safe turn, your velocity must be, or it can go maximum. How, what maximum velocity you can have? That will be mu rg square root. Okay, without slipping. That is V max without slipping. Got it?
Yes.
So you can calculate, if you are turning on a track, you can calculate it that by what maximum velocity I can turn. Okay. So that formula is very important. Just write it down.
Okay, sir. Are we going to do some questions about it? This seems a
Yeah,
little
we'll
bit
see.
complicated.
We'll see that question.
Not like exactly understand.
Yeah. Okay, just write down the formula.
And like this chapter, I'm mainly feeling if I'm not able to apply the formula correctly to the question, like when to use what, how to approach it, that's where I'm facing difficulty.
If you doing practice and practice and practice, then only you will understand how to apply that formula. Okay,
Okay.
note it down.
Yes.
Okay, now we'll do questions based upon this formula. We'll do it once. Yeah, this question 72. Give it a try.
72. Okay.
Yeah.
Internal level road.
Radius is given to you. Maximum
Yeah.
speed you need to find,
And
which is
please you put it in the formula.
yeah, without skidding if the coefficient of friction between the tires and road is 0.8.
Root 800.
Yeah.
Am I correct?
How much?
I said root 800.
Root 800. Yeah, right. If you're taking G as 9.8. Okay, take it G as 8. Yeah, root 800. You are right. Okay. So you understood how we can apply that formula?
Yes, sir.
Okay.
If there's no friction, then the car can infinitely speed up.
If there is no friction, that means without friction your motion is not possible.
Oh,
Is
yeah.
it?
No, but in a condition if the car is moving, then it can infinitely speed up without having to stop.
Yeah, if there is no friction, so that means it is not going on the ground. Okay, that means it is moving in the air. Got it?
Yeah.
Okay. Now, do you want to again do this 73rd? Same type of question it is. Try to do it.
Okay. Okay, sir.
Sanvi, Aditya, Parikshit, Pratim, welcome you all. Sanvi, the formula is V equal to, we're talking about centripetal force. So V maximum will be mu Rg, on which driver can go without skidding, and the centripetal force is mv square by r. First of all, find centripetal force.
Yes, sir. Found that.
Okay. And then find the coefficient of friction. And that centripetal force will be equal to the force of friction, isn't it?
Yes.
That helps very much in Formula 1 driving. Okay. On the racing tracks also. They calculate. They already calculate every turn what is the friction and what is the maximum speed they can pass through that special turn. Okay.
Yes, sir. Done.
Done. What is the force of that frictional force is what?
0.78.
0.78.
Yeah, the. Oh, 1 second.
Coefficient
No,
of
but it
friction.
should be equal to the centripetal force, right?
Yes.
And like I just found the centripetal force.
Yeah.
Did I do something wrong in my calculation? No, sir, I did everything correctly.
Okay.
It should be 0.78.
Yeah, but it is your coefficient of friction. Coefficient of friction is 0.78. Okay. Got it?
Wow.
See,
I found out, I was
if
trying to
you
find it.
if you apply this formula, F is equal to mv square upon r. What is m?
Yeah.
M is 1500 kg. So that is 1500 into V is what? With a speed of 12.5 meter per second. So if you multiply 12.5 square divided by the radius 20 meter. So that will be, if you solve it all, that will give you 1.172 into 10 to the power 4 Newton. 1.172 into 10 to the power 4 Newton. So that will be your centripetal force, and that centripetal force will be equal to the force of friction, isn't it?
Oh, so I actually found out the maximum velocity. I didn't read it. We need to find out the frictional force.
Yeah, but friction force is asked here, friction force and
Well,
the coefficient of friction. So
I
friction,
accidentally found out the maximum velocity, and then I tried to find out the frictional force and
and that
ended
is
up
the
with
formula for
this.
friction force. So in that formula, mu will be given by F by mg. So if you calculate, if you put that friction of force here, 1.17 to 10 to the power 4 divided by mg, so that will be given as 0.8. Sorry, if you calculate it, it will give you 0.8. So that will be your coefficient of friction. Got it?
Yes.
Okay, can we talk about next topic, circular motion of a car on a banked road? So that was the scenario where your road was plain. Okay, now it is a banked road. Banked means
Bank means
it is not horizontal,
yeah.
it is it is just angled like theta here given here. Okay, can you see this picture?
Yeah.
Okay, so in this picture, just figure out what force is in which direction. You just need to figure it out. Okay,
Okay, sir.
so that weight is also working towards downward, so that will be mg, isn't it?
Yeah.
Let us say this road is inclined at an angle of theta with the horizontal.
Okay.
It is inclined at theta angle. So what happens? The force of friction is always along the surface, isn't it?
Yes.
So let us say this is your force of friction, this one. So if this is your force of friction, so it will have two components. This force of
Yes.
friction will have two components, that is F cos theta and F sin theta.
Sin theta.
Okay. So this downward component will be, this will be having F sin theta downward, and horizontally it will be having F cos theta. Got my point?
Yes.
Okay. So how many horizontal force you have?
We have
R sin theta
a sin theta
and F cos theta.
and cos theta.
So
2.
that
Yeah.
that two horizontal forces will produce centripetal force, isn't it? Hello.
Yeah.
Okay. So that means your R sin theta plus F cos theta will give you mv square by R. That is your first equation. Do you understand it?
Yes.
Okay. So what is the vertical forces? How many are the vertical forces?
Vertical force. Uh, there should be only one. Yeah, one.
That mg and F sin theta, they are downward and R cos theta is upward, so they will
Yeah.
balance each other.
Yeah, but there's only one upward, right?
Yeah, that is one upward. So that means mg plus F sin theta will give you R cos theta. So that will be your second equation. Do you understand it?
Yes.
Okay. So that was only the magic. So now you can put your force of friction as mu r, or you can say mu mg. Okay. So you put F as mu r in each of the equation. Are you getting my point?
Yes, sir.
Okay. So now basically we need to find velocity. We need to find the velocity by which it can take turn safely. Okay. So I am not solving it. You just need to put it everything into this equation. So that equation will give you the long formula, that is V is equal to Rg into, just write down this formula, V is equal to Rg into mu plus tan theta upon 1 minus mu tan theta. Mu plus tan theta upon 1 minus mu tan theta, and that's whole under root. Okay. So this will be the scenario if the road is banked. Got my point?
Yes.
Okay. So if there is a special case, if mu is 0, what will happen? Special case, if mu is 0, then what will happen? V is equal to Rg tan theta. Isn't it? Vihan, please note it
Yeah.
down.
Yes, sir. I'm noting it down.
Okay. So please note down this formula. So in that case, what will happen? What about tan theta? So tan theta will be V square by Rg. So tan theta will be V square by Rg. That means theta is equal to tan inverse V square by Rg. Okay. So that is the relation between
So the things you wrote on the right side is not clearly visible.
this side.
Yeah.
Okay, just I'll try to write it down by black pen. Now it is visible.
Yes.
If mu is equal to 0, then V is equal to Rg tan theta square root. Then tan theta will be V square by Rg. Okay.
Yes.
So that is the angle of banking. That theta is said to be angle of banking. It is very, very important. So what is theta? Theta is angle of banking. Banking of road. So on turns also it is calculated theta. If
Yeah.
there is more theta, then you may fall. So that is on every turn it is calculated.
Okay.
Got it? So once we make road, so this theta is to be considered always, even on railway line also. There is a turn, so you just see that, you just observe it. The railway line is just, you will feel it like it is bank. Okay?
Yes.
There is some type of slope. Got my point?
Yeah.
Okay. So I'll finish another topic also, that is bending of cyclist. Okay.
Okay.
It is just like the same point. We'll cover it, and I'll do the exercise. I'll send you the exercise so that you can make it. Just see the concept. This is a cyclist, and it is just, if you are, do you run a bicycle?
Yeah.
Okay. So what you do if you are on a circle?
I turn the handle.
You turn the handle, but you just banked it towards circle,
Okay.
isn't it?
Yeah, towards the center of the circle. Yes.
Yeah. So this is your bending. Let us say the bending from vertical, it is theta. Got it?
Okay.
So how many forces are applied once you are taking turn on a circle? So that mg will be downward, isn't it?
Yeah.
And because that is the contact, so that will be perpendicular, that reaction force, that will be r. And as you say it is theta, this angle is theta, so that will be r cos theta, and this will be r sin theta. Mg will be downward, so mg will be balanced by r cos theta, isn't it?
Yes.
And r sin theta will be balanced by what?
Awesome.
It will give you centripetal force, because it is inward. Okay?
Yes.
So in that scenario, your r sin theta will be mv square by r. Okay?
Okay.
And r cos theta will give you mg.
Yes.
So if you divide both the equations, you will get r sin theta by r cos theta equal to mv square by r divided by mg. Mm cancelled, r cancelled, it is your tan theta is equal to v square by rg. So theta will be tan inverse v square by rg. So that will be your angle of banking, yeah, or you can say
Okay.
that is the same. That is the same you have studied in case of car, isn't
Yeah.
it?
Yes.
Okay. So that means angle theta, on which it depends? Theta depending upon velocity.
Yes.
If velocity, or you can say, if we write v is rg tan theta square root, so v is depending upon r.
Yes.
If the greater radius, greater can be the speed.
Yeah.
Okay. Tan theta, if theta is more, then speed can be more. Okay.
Yes.
So these are the theoretical part. Vertical motion is also, motion in a vertical circle is also pending, and just send me the topics which are pending, which we didn't study. Okay,
Okay.
so that we can do it in the next class. But what is your job? Your job is to do these questions. 72 we did, 73 we also did. Okay,
Yeah.
74 you need to do, 75, 76, 77, 8, 79, and these are the problems for practice. Okay, on
Okay.
this topic.
This is for circular motion, right? Everything.
Yeah,
Okay.
this is circular motion. So you just do it, and whatever topic we didn't cover, just send me the topics also, so that I can cover everything in tomorrow's class. And if there is any doubt, so tomorrow's class will also be going to be happen at 2 o'clock. Okay,
Also at 2.
yeah,
Okay.
I'll send you this exercise and the PDF. Okay
Okay,
then,
sir.
Vihan, meet you tomorrow.
Bye.
Bye bye, see you.
Bye, sir. Have a nice day.